Integration by parts is a useful tool when you're trying to integrate the product of functions. Now let's review the product rule for differentiation. d dx of uv is equal to u dv dx plus v du dx. And I can write this as u v prime. Now remember, if I want the antiderivative of this, uv is going to be the integral of u v prime dx plus the integral of v u prime dx, or I can just write this as the integral of u dv plus the integral of v du. Now in general, you've got just an integral of a u dv. So let me solve this. So if I want to integrate u dv, that's going to be u times v minus the integral of v du. And as a matter of fact, this is what we call integration by parts. Now, there are some general guidelines. In general, you want dv to be the most complicated part of the integrand that you can integrate, and then u is everything else. Or you can let u be the portion whose derivative is a function that's simpler than u, and then let dv be the remaining parts. But again, you have to be able to integrate dv. Here are some general steps I want you to follow. I want you to write the integral itself and identify u. And you're literally going to put u equals and write that in your blank. Then you're going to take du. The next thing I want you to do is identify dv and literally write it down. And then integrate to find v. I want you to write this equation right here, the rule for integration by parts. And then I want you to evaluate it. Sometimes once is enough, sometimes it's not. Sometimes you have to repeat till you don't have any more integrations. Let's look at a classic example of why you would use integration by parts. The integral of x e to the x dx. Now, in this case, let's let let's let u equal x. And dv is e to the x dx. Well, du is just dx, and v is going to be the integration of this, which is just e to the x. Now don't worry about your plus c's. Those will come into play later. So that's the first step. Now I want you to write down the rule. U dv is equal to uv minus the integral of v du. And now plug in what you have. The integral of x e to the x dx is equal to uv, so you've got this situation right here. So it's x e to the x minus the integral of v, and v is e to the x, du. So this is x e to the x minus, e to the x plus c. Now, in this case, you might be thinking you want to let x squared equal u and log x dx equal dv, but I can't integrate log of x. So since I can't integrate log of x, I'm going to let u equal the log of x. And that leaves dv being x squared dx. Now, the derivative of u is, when I find du, this is going to be dx over x. And now I have to integrate this term. V is x cubed over 3. So now I want the integral of u dv is equal to u times v minus the integral of v du. So this is u times v, so this is 1/3 x cubed log of x minus the integral of v, so x cubed over 3 du. So this is dx over x. Let me rewrite this as x cubed, natural log of x over 3. I don't care if you leave that factored out there, that's fine. Minus 1/3 the integral of x squared dx. So this is going to simplify quite nicely as x cubed log of x over 3 minus, this is going to be 1/3 divided by 3, so 1/9 x cubed plus c.